Hello everyone, my name is Vasyl Kiyko and today I will continue speak about forest cover type classification. So, selected algorithm is KNearest Neighbor. KNearest Neighbor algorithm assumes a similarity between the new case data and available cases and put the new case into the category that is most similar to the available categories. KNN algorithm stores all the available data and classifies a new data point based on the similarity. This means when new data appears, then it can be easily classified into a well-suited category by using KNN algorithm. How does it work? At first, select the number k of the neighbors. Next, calculate the Euclidean distance of k number of neighbors. Euclidean distance you can see on the picture in the right. Step 3. Take the k nearest neighbors as per the calculated Euclidean distance. Step 4. Among these k neighbors, count the number of the data points in each category. Step 5. Assign the new data points to that category for which the number of the neighbor is maximum. And step 6. Our model is ready. So why I choose KNN algorithm? Because it's simple to implement, it's robust to the noisy training data, it can be more effective if the training data is large, which is my case. But it has disadvantages. Always needs to determine the value of k, which may be complex sometime. The computation cost is high because of calculating the distances between the data points for all the training samples. On this slide you can see tools which I used during work with this project. As main language is Python and as useful libraries is pandas, numpi, scikit-learn and Jupyter notebook. And some about each tool. Python. From development to deployment and maintenance, Python helps developers to be productive and confident about the software they are building. Benefits that make Python the best fit for machine learning and artificial intelligence-based projects include simplicity and consistency, access to great libraries and frameworks for AI and machine learning, flexibility, platform independence, and wide community. Scikit-learn and pandas. The first is simple and efficient tools for predictive data analysis, accessible to everybody and reusable in various contexts, built on numpy, scipy and matplotlib, and open source, commercial usable. And pandas aims to be the fundamental high-level building block for doing practical, real-world data analysis in Python. Additionally, it has the broader goal of becoming the most powerful and flexible open-source data analysis manipulation tool available in any language. Next is NumPy and Jupyter. NumPy is a fundamental package for scientific computing with Python. It contains, among other things, a powerful n-dimensional array object, sophisticated functions, tools for integrating C, C++ and Fortran code, useful linear algebra, Fourier transform, and random number capabilities. Besides its obvious scientific use, NumPy can also be used as an efficient multidimensional container of generic data. Arbitrary data types can be defined. This allows NumPy to seamlessly and speedily integrate with a wide variety of databases. The Jupyter Notebook is an open-source web application that allows you to create and share documents that contains live code, equations, visualizations, and narrative text. Uses include data cleaning and transformation, numerical simulation, statistical modeling, data visualization, machine learning, and much more. And in my case, I use Jupyter Notebook for data visualization. So, okay, we came to system functionality. In this use case diagram, you can see the main actors and scenery. First of all, the system receives data from database to fit the model. Then, the drone gives the system data to predict. And the system, by using model, predict value and make a report. In the left, you can see the activity diagram. Here we can see the main activities. First of all, system receive data for model, then it fits model, and then get data to predict and make prediction. Then depends on option. System makes single message or adds result to main report. Then send predicted data to database and prediction to researcher. And the last but not the least, the sequence diagram. There we can see that at first database give data for studying to system, and system pass this data to model. Then model feed, and then drone give data to predict for system. System pass this data to model, and model makes a prediction. Then it returns prediction results. System makes single result or add result to report, and send production result to database and researcher. So, data analysis. Before fitting model, I worked with data. In this slide you can see the percentage of each tree type in the data. The least frequent type is cottonwood, which is cover type 4. And the most frequent type is lodgepole pine, which is cover type 2. There you can see distribution of tree types by place of growth. Below the diagram you can see panoramas of each area: Rava, Neota, Kamanj Peak and Kozla Podge. And correlation matrix. As can be seen from the matrix, a high relationship is observed between the values of hillshade 3 pm and hillshade 9 am, aspect and hillshade 3 pm, horizontal distance to hydrology and vertical distance to hydrology, and so on. Then I fit a model. First I tried different k values and found out that k equals 3 is the best k, because 1 has long work time. However, it's the most accuracy. On the right, there is a confusion matrix. There you can see score of some predicted values. This model accuracy is 95%. In spite of my system hasn't graphic user interface to present you functionality of the system, I've decided to make simple graphic user interface using Flask, a lightweighting VSGI web application framework. It's designed to make getting started quick and easy. Also, time to feed model on my PC is large, it's something like 10 minutes. So to save time, I have made a model in advance and saved it using Python's model pickle for quick start and quick using. So now let's see how it works. There you can see the form for data input. In the future, this data will be collected by the drone system and transmitted for analysis. But for now, let's add some of the data manually. I did it in advance. I set elevation, this elevation, this aspect, slope, horizontal distances, different hillshade, and choose the area number 1 and soil type number 29, which is lake con. And then I make a prediction, and a prediction tree is aspen. So the prediction is made. So during this work, I've developed a model that determines the type of forest cover based on surrounding features using machine learning that could form a part of the project now being developed to monitor the condition of trees using drones. The project aims at simplifying and practically automating the control and monitoring of trees using drones and machine learning to improve the forest situation. I hope this work will help other people and scientific researchers look after our nature and save it. That's all. Thanks for attention.